All right. Well, thank you all. Welcome to this webinar on ash tree inventory. We're super excited to have this as part of the 2023 Maine Land Conservation Conference. Thank you so much to Ella McDonald, Tyler Everett, Emily Francis, and John Daigle for approaching us and being willing to collaborate and make this a part of this year's conference. If you're just joining us, everyone, I'm gonna another quick reminder to please mute your microphone, at least to start with here. I think there's going to be an opportunity for some questions and speaking later in the session, but if you could put your microphone on mute right now, that will help us out. So I'm going to take just a moment here and bear with me, everyone. I'd like to read a land acknowledgement. So we want to take a moment to pause and remember that the forests, rivers, and coastlines of Maine are the ancestral and present-day homeland of the Wabanaki. Words are never enough, and actions will speak louder than any words. But there is growing commitment among many of the land trusts around Maine to make connections and build relationships with Wabanaki communities around land and its stewardship. I'd like to express sincere gratitude to the Wabanaki who are giving time and energy to the Maine Land Trust community. And we commit to continuing to proactively create opportunities for joint conversations and learning around cultural resources and Wabanaki priorities and access. Well, thank you again. I think we will dive right in and get started. So I'm going to hand the mic over to Tyler. Take it away.
Thank you, Donna. Let me pull up my slideshow here. There, how's that? Is everyone seeing that?
That's great, perfect. Tyler. Yeah.
Okay. Basul, Ipchalasi, Wabanoke, Weig, Mi'kmaq, Talawisi, Tyler Everett, Uladet, Ash Protection Collaboration across Wabanagi, Ganadiag, Wally Waddle, Wiskook. Greetings, welcome. I'm a person of the dawn. I'm Mi'kmaq, and my name is Tyler Everett. Here at the Ash Protection Collaboration across Wabanagi, we put a lot of effort toward taking good care of brown ash. So today we're going to have a discussion of ash inventory and key identifying characteristics for ash trees in the Dawnland. And like I said, I'm a part of the Ash Protection Collaboration across Wabanagi, or the APCA Lab. You see a bunch of us floating around in the participant window pane. And we hope to see some people in the field tomorrow for an inventory field tour, the Appleton Bog Preserve, and then also in person at the annual meeting. Just a quick overview of what I'll be covering today. I'm going to talk about why we should inventory our ash resource. I'll talk about northeastern ash species identification, talk about determining the sex of an ash tree, and then because we're the APCA lab and we're really focused on brown ash, I'll focus in a little bit on delineating a brown ash corridor, and then I'll end with some emerald ash borer signs and symptoms. Probably should have moved that up so that we didn't end on the bad note, but it is what it is. All right, so why should we inventory our ash resource? The baseline knowledge needed to manage any resource revolves around knowing how much of the resource we have and where it's located, and we can establish this through forest inventory. In the case of the emerald ash borer, there is certainly a strong need for early detection, so identifying sites for launching funnel traps, purple traps, or installing trap trees is made much easier when you have some sort of inventory of your ash stands to go off of. Inventory can also provide vital information that's useful in timing harvests that abut these stands, so upland stands that are adjacent to some of these brown ash wetland forests or other ash forests. And then in general, it can simply expand our knowledge on emerald ash borer, the ash species that are here in the Northeast, and maybe even basket quality ash sites. Involving basket makers in the assessment of these stands can help create cultural access, a sharing of knowledge and understanding of different ways of knowing, and it can help establish reciprocity and relationship building with tribal nations here in the Northeast, in the Dawnland, the Wabanaki. Then lastly, as we consider various adaptive management strategies for emerald ash borer, we can better improve the timing of those and the implementation of those as a part of a greater integrated pest management approach. And that's all at the start with inventory. So good, sound inventory data is the starting point. Here in the Northeast, we have 3 primary species of ash trees found naturally on the landscape, each serving a different ecological, social, and economic role that make the conservation of that species important in their own regard. We have brown or black ash, Fraxinus nigra. We have green ash, Fraxinus pennsylvanica. And lastly, we have white ash, Fraxinus americana. When it comes to the composition of Maine's forest, these ash trees make up about 4% of our total forested lands. In our hardwood forest, that percentage jumps to about 6%. Actually, I'll go back. And so here, this map here on the right, green area across the kind of central belt of Maine is the basal area of ash. I think a lot of people have seen this map, but there's a big concentration kind of running through the middle part of the state. And so it's not the most abundant, but even 3%, 4%, 6% of the forest is that's a lot of trees, because we're a very heavily forested state. So it's definitely an important resource to think about in the face of emerald ash borer. All ash trees exhibit an opposite branching structure. So on the left here, you can see an example of an opposite branching and then an alternate branching. And so that's one of the key characteristics we can look at first, is that branching pattern. The tips of those branches are very blunt for ash trees too. So as you look at the profile of the forest a ways away from you, you can really kind of see, they kind of look like fingers standing up into the sky. And then the leaf of ash trees is a compound leaf, not a simple leaf. So a simple leaf has just one blade, whereas a compound leaf has all these blades coming off of the midrib. Might as well break up my pointer early here. This is the midrib on a compound leaf, and this is the midrib on a simple leaf. And so that's a good characteristic to focus in on. I'm sure we've all seen ash leaves and know what I mean there. So at the center of the work APCA is involved in is the brown ash or black ash tree, Fraxinus nigra. Wizcook is the Mi'kmaq word for brown ash. This is the ash tree in the Northeast that likes its feet wet. This tree is viewed by wetland scientists as a wetland obligate species across its range. So when you come across it, you should be in a wetland area, but I do think it's a bit more of a realized niche. I think that I've found it in areas where it's not as wet, but generally speaking, you should have your muck boots on. This is a shade intolerant tree, so shade intolerant in nature, and that results in us finding lots of even age stands, but where they reside is far from what you would consider an ideal site for a tree to grow and survive. But they not only survive, they thrive in these really rough, really tough sites. Really wet sites. They're saturated much of the growing season. And over time, with that tough site comes lots of disturbances like native borers, fungal pathogens, and they knock out overstory dwellers. And so it's not uncommon to see lots of dying overstory trees with new cohorts of brown ash moving their way into the freed growing space. The best recognition factors. So these are we called them in my dendrology class BARFs. So your best recognition factors, your BARFs. These are what you key in on when you try to find out exactly what tree you're looking at. And so for brown ash or this ash tree, it's irregularly scaly, flaky bark. It's kind of corky in texture, popcorn-esque, you might say. The bark color varies from gray to brown. In the upper right of the screen is a diagram of a leaf scar for brown ash. Leaf scars are the literal scar left behind when a tree casts away its leaves in the fall. The shape and orientation of the bundle scars, which are the small vessel elements that you can see inside the leaf scar, are great tools for distinguishing between the three ash species we find in Maine. For brown ash, the leaf scar often has little to no notch. The notch is established by the axillary bud. So there's a little bud above the petiole of the leaf, and that kind of juts into the stem, and it causes this little notch on the leaf scar. Not always. And in fact, with brown ash, there's often little to no notch when you look at their leaf scar. And what that causes is all those bundle scars, those little vessel elements, to create almost a full circle. And so that's kind of a characteristic that you can really key in on for brown ash. In the fall, just before these leaf scars would become visible, the leaves turn a yellow-green. What's more distinct about these leaves are the leaflets. So if we look closely, this is not a very blown up picture, excuse me. But each of the individual leaflets on the compound leaf for a brown ash, they're sessile to the midrib, meaning they attach directly. So there's not a small petiole at the base of the leaflet that connects it to the midrib. And for the other two ash species, there is. So that's an important distinguishing factor. The buds for brown ash trees are dark brown to black in color, and I think they resemble a Hershey kiss. So either milk chocolate or dark chocolate, depends on the tree. Here we have green ash, or Fraxinus pennsylvanica, Lanocum wiscook, which means greenwood ash, which is not a dedicated word for this tree in the Mi'kmaq language. I just wrote it this way. We don't have a word for green ash in the Mi'kmaq language, to my knowledge anyway. But it's interesting, and it relates to a story my grandmother told me. Both my grandmother, or my great-grandmother, and my great-grandfather made brown ash baskets. My grandfather was very crafty and made a lot of baskets, is what my family tells me. When in the county, the family made potato baskets, and eventually our family moved south and sold fancy baskets in the Portland area. My grandmother specifically remembers, and she's told me this a couple times, that my grandfather complained when they first made the move about the quality of the ash. He said that the ash sucked down here. And I don't think that they interacted with green ash at all in Nova Scotia or in the county for that matter when they were developing their craft. But down in southern Maine, white ash and green ash are just far more abundant in our forests than brown ash. And so I don't know if it was white or green that my grandfather was messing around with, but I think, or I suspect it was green ash. And green ash is less abundant than white ash, but it is definitely more prevalent than brown ash in southern Maine, in my opinion. And so I think that gives a reason as to why we don't have a word for green ash in the Mi'kmaq language, to my knowledge anyway. Green ash is found intermittently along the margins of wetland areas and within sweeping swales across the northeast landscape. It's the most common ash street tree or shade tree in residential or urban areas. And the barfs, or the best recognition factors to key in on for this ash tree, are the slightly furrowed bark that almost appears to be a woven basket. It kind of gives this basket-like appearance to the bark. And then, like I had mentioned, the leaflets have these stalks attaching them to the midrib. And so you can kind of see them here on this leaf. The leaf scars exhibit a slightly larger notch than that of brown ash. And that's again because of the axillary bud, which forces the bundle scars on this leaf scar, and I have another diagram up here, to be U-shaped. So it's kind of like at a U here. The twigs are also hairy, and this is the only tree that has these little downy hairs on the twigs. They're not as like obvious on some trees, so it's not a foolproof way of identifying green ash, but you can key in on that. And then in the fall, green ash turn a yellow or bronze color in the fall. And lastly, we have white ash, or Fraxinus americana, Ocamuk, which is Migma for white ash. And it often occurs as a scattered large overstory tree in our hardwood forests, occupying the upper reaches of the forest canopy. So it serves this unique ecological niche by adding structural diversity to our forests. The best recognition factors or barfs for this ash tree are a deeper fissured bark compared to brown ash. And you don't get quite the basket-like tight weaving, but what you do get are these really distinct diamonds in the bark. You can kind of see that pretty well in this picture here. These twigs on white ash are hairless, and sometimes they're even like a purple color. White ash leaf scars have an even deeper notch than that of green ash. And again, that's because of that axillary bud. And so the bundle scars here, I say it's like a crescent shape. You see this crescent shape here, really deep notch because of the axillary bud. The leaflets of this compound leaf also have those petioles, or those, they're not actually called petioles, there's a specific term for that type of petiole. It's like a petiole something. It's a unique word, but again, that space off the midrib is a good key factor. And then in the fall, if you've seen white ash, these trees turn a maroon color to a purple color. And sometimes, like I had said earlier, you can see that purplish color on the twig. And if the tree is female, you can see that purple color on the seed samaras sometimes. Here we can see those leaf scars side by side. This particular picture doesn't have a great green ash example, in my opinion. It doesn't really distinguish clearly how it differs from white ash. But I think that's a lesson all in its own. When you think about bark morphology, twig morphology, bud morphology, and leaf scar morphology, it varies all the time. So that's fine though, right? Because we're all tree nerds, and so would it really be all that fun if we didn't spend 10 minutes arguing on whether it's white, green, or brown or black ash in the forest? I think we all enjoy those arguments. While doing inventory can also be very useful to identify the sex of an ash tree. While doing inventory, you could come across 4 different types of ash trees with regard to their gender. Ash trees are largely dioecious, meaning the tree will have either female flowers or male flowers. The female flowers are seen here on the left, and the male flowers here on the right. The female flowers, they look starkly different than the male flowers. The female flowers are really wispy, and Nate Siegert's on the call. He's the one that uses that word to describe them, really wispy. And then these male flowers, they look really globular, and they're like directly adhered to the stem of the branch. So they're really sessile to the branch. Whereas these wispy outgrowths, they're really dichotomized. If this female flower becomes fertilized by a male flower, that's when we get the seed samaras, right? Circle of life, the birds and the bees. So if we get the fruit to develop on this female tree, at the end of each of these little tips on the dichotomized stems is where you'd see the fruit form. And there are these huge clusters of winged samaras, straight winged samaras. And we had a great seed year last year. It'd be awesome if while we're in the field, we get an opportunity to see some flower production, but sometimes it's 8 years between seed bumps for ash trees. Now, aside from male and female individuals, you could come across 2 types of polygamous individuals. You could see an individual with female flowers and then also polygamous flowers on different branches. And then you could see one with male flowers and then polygamous flowers on other branches. The polygamous flowers, they just kind of show a mix of both characteristics. They're kind of like a mix up of the two like key characteristics. So they're a little bit longer, but they're globular looking, just enough to throw you off and make you wonder what you're looking at. But a lot of times the male flowers and the polygamous flowers, if they get infested by a gall mite, they get these large black growths on them, and those stand out like really easily in the canopy. So that's a great way to identify if you're looking at a male tree or at least a polygamous tree. Let's see here. So we've covered leaves, bark, twigs, leaf scars, and the reproductive structures. But what about the seeds? Ash trees produce, like I said, a straight-winged samara. Green ash is all the way on the left here. It has a wing terminal end to the samara, which tapers into the fruit body pretty quickly. But then if you look at the actual fruit body, so I'm talking, this is the winged section, and then this is the fruit body. And so real quick taper into the fruit body on the wing. But then you've got this really gradual taper into the wing section of the seed samara. It's also really long and thin. And then you get this little bit of a curve at the end of a lot of green ash seed samaras. And then for white ash, seeds have a larger cigar-shaped fruit body that more abruptly shifts over to the wing. And so like you can really distinctly see the edge of this fruit body on this seed samara. Then overall, the seed samara is like kind of a teardrop shape. That's what I describe it as. And again, if you catch it at the right time of year, you sometimes see that purple kind of hue to the wing section anyway of white ash seed samaras. And that can tell you you're looking at a white ash seed. But green ash and white ash, they're really distinctly different. And then brown ash has a wing margin that surrounds the seed. And so again, you can kind of, it's a really hard seed because it's all brown, but right here you can see the edge of that seed body. Up here, it's harder to tell, but especially early on when these are still green, you can really see the margin of this seed, fruit body. And so it clearly shows that the wing section fully encompasses the fruit body. And then I think another great thing to remember brown ash seed samaras, brown ash is culturally significant to the Wabanaki, the people of the Don. And traditionally, our rivers were our highways. That's how we got around. And so we would do that in a canoe. And canoe paddles would be critically important to that locomotion. So this kind of looks like the blade of a canoe paddle. And so you can kind of connect those two culturally important things together there. So now we're going to move on to the inventory process. You got some skills on how to identify the 3 ash species, but now let's talk more about inventory. In my master's program, I wrote an inventory manual for brown ash wetland forests, and I can share that link with anybody that would be interested in looking at it. The goal there in that protocol was that I would collect a whole suite of data that would allow a forest manager with a tribal nation to bring the management of that ash forest in any direction they saw fit. And so it's a very comprehensive data collection. Maybe more so than is necessary, but it's always great to have more data than you need, because it's harder to get back out in the field and collect it. The Passamaquoddy Forestry Department adopted this ash inventory protocol, and they just finished up inventory of their ash stands. I work for the Passamaquoddy Forestry Department, so I was part of that work, and we went the route of taking a variety of pre-existing data sets and putting them together on a map. And then we all got together and looked, we hooked up the computer to to the TV so we could all see it. And then we toggled on and off all those different data layers. And with those various data layers, we were able to kind of come up with some points on the map where we thought there would be a significant chance that we'd come across brown ash. And those were recon points. I made all these recon maps. Everyone had these sitting in their trucks. And then while you were doing your typical work, you got to go do a boundary line, flag a block line, go find a corner. Maybe someone's got a hunting stand somewhere and it shouldn't be. While you're doing that work, if you came close to a brown ash recon point, you'd go and check and see if there's ash. And so it's a simple presence absence check. Once you got to the recon point though, and you came across brown ash, you could do one of two things. You could simply drop a point if you were in a time crunch and label it as ash confirmed and then get it to me for the GIS thing. Or you could take a closer look at the site by walking the perimeter. And we call that here on the slide, if time allows, walk the perimeter of the ash chain using the clockwise sight and go technique, patent pending. Right here, that's what that looks like. Here's a little video of that process. So you just go to the stand, you find an ash tree on the edge, you touch it, and then you scan to the left, and the first ash tree you see, you gotta walk to it and then repeat the process. And so as you touch all these ash trees all the way around the outside, one, you get to familiarize yourself with the site. But if you've turned the GPS on to tracking, which I know none of us on the call have ever forgot to do that, then you get the perimeter of that ash stand. And then you can bring that into GIS and set up a more formal inventory, or you can stop there. I mean, knowing the location of the site and the structure of that site, that's really valuable data. And you can make sure that, timber harvest don't put a skid trail through it. You can make sure that if basket makers reach out, they know where to go. It can be really valuable just to have that. In the inventory manual, I share a case study application of the protocol on an ash stand in the university forest. And so this is the process I used there for delineating the brown ash corridor. To kick things off, like Passamaquoddy did, you utilize existing data sets. So maybe you have existing forest inventory data for the land base, data that you already have. It could be even just cover typing. But more useful than any of those existing data sets is firsthand reports. You are all on the land navigating as managers. You're on foot in some capacity in the forest. If you come across ash, or if you've come across it and you can roughly identify where it is, those are the best starting points. Just go to that area and do a quick scan and search of the area. I mean, we know it likes its feet wet, so go to the wet areas. But having those firsthand sightings or encounters of brown ash are hugely important, which is a great thing to note, because on your day-to-day work as a land manager, you can just make that a part of your practice all the time. Every time you come across brown ash, just drop a point. Here at APCA, we love to hear about those points. Basket makers and ash harvesters would love to connect with you about potentially harvesting basket quality trees. And so that's an easy thing you can do in your day-to-day work. In this protocol, next you pull a map of that general area and bring in the hydrological data. So streams, lakes, rivers, in the National Wetlands Inventory. Again, brown ash loves to have its feet wet, so these are key. Then you bring in the soil data. I just use the Web Soil Survey application online through USGS. Here you can see the soil series abbreviated with 3-letter codes. I know you can't read them, they're too small. But then they're also color coded. So the colors correspond to the depth to water table. So kind of a twofold data set there. Not shown here, but another key data layer is contour lines. That would tell you where this falls topographically. We know that brown ash likes the low areas, so that's a good data set as well. This is going to start to tell you where brown ash is likely to occur. You know that this is a wet area. You've got this soil series. The contour lines would also illuminate this area. And so you could just start right here by trying to create an area to do inventory, or you could do some recon. Go out here and check this site out. Excuse me. So let's say you did do an inventory of the area. Again, it's going to be paramount that you just take a couple of additions to your protocol. If you come across brown ash during an actual inventory at a plot, it's going to be picked up in the data. But one thing you could add to that, here we have these little pencil marks. And so as you were doing inventory and you're navigating from plot 1 over here somewhere to plot 2, you can just drop a point on your GPS and say, hey, I encountered brown ash right here. Then you navigate to plot 2. This one happened to pick up some brown ash. That's what these green dots indicate. And so this is an existing inventory data set. You know, it could have been an inventory for a timber sale. And then also these reports of brown ash. So you've got this national wetlands inventory, this soil series, depth to water table, the contour lines if they were on here, and then these little data points. And you really start to see where brown ash is occurring. Just to take a little step back, let's say that you've done that recon and you started to do that inventory. It's set up like a variable radius inventory plot. And so, for instance, this could be what you set up. These are inventory plots that'll be variable radius cruising. And you navigate to each plot. It's on a grid-like pattern. It's a great way for capturing a geographic area relatively quickly, because you know what direction you're going to head to the next plot. The distance is the same. You could do random plots. You could do different setups here. That's just what we chose to do. These plots are only 4 chains apart, about 264 feet. And that's about a plot for every 1.5 acres. That's way too many plots for your typical cruise. So this is kind of like a non-realistic example, but it does do a lot here in showing how small these sites can be. We've got this brown ash stand in here, and we showed where it was occurring. This is the same inventory where these notes were made on this slide. So you've got 2 plots in that whole inventory that actually picked up brown ash. So it just goes to show, just goes to show if only these 2 plots out of all of them actually even picked up brown ash, how easy it can be missed on the landscape. And so the recon technique is the way to go, is what I'm getting at. Go out and check these sites where you think brown ash is, get the actual corridor, and then put some plots within it. You're going to have a way more effective data set. But in that variable radius cruising, you're going to want to collect a suite of data. I'm just going to quickly go over what some of those data could be. And this is, again, from the protocol that I did in my master's program. So you could divide that data up into plot level data and tree level data. Here, we're going to look at plot level data. So if you navigate to the plot, you got plot number. We take aspect, the percent slope, the elevation of that particular plot. And then we also look for invasive species. So here in this case, plot 1 had some honeysuckle. Hopefully we don't see any invasive vegetation. from a management standpoint in brown ash wetlands and in all wetland places, I mean, you've all seen this, invasive vegetation is really problematic to getting the regeneration that you'd like. And in this case, we want to see new generations of brown ash. The microtopography, there's a little code that you could use. And what this is for replanting. If I wanted to go in here and plant brown ash, the mounds, the pit and mound topography of the site, the greater success is on those mounds. And so what is the degree of mounding at that site? That's basically what this little chart describes. It's a useful tool to do that. At the tree level, you want to also collect some tree specific data. So here's the tree data sheet, and here's an example of some of that data filled in. So here's a look at what that data sheet might look like. I've circled, all right, I removed those circles actually. As you can see here, that tree number 8 is what we're at, and it starts at the top of the sheet. In my protocol, we do heights on every 10th tree, and that's because if you do big bath or you do other techniques that are common in forestry to figure out what your height trees are, it's favoring trees that are larger. And brown ash is oftentimes not the larger tree. So if we're trying to inventory ash, we don't want to favor the larger trees for height. We want to capture an unbiased, well, a little bit biased. If you can choose to do an ash tree, that's great. But a lot of times you want to be unbiased. So you want to make sure you're capturing heights on all these different trees. So you've got the plot number, the tree number. It's just a rolling count as you do inventory plot to plot. So at plot 1, you inventoried 7 trees. Here at plot 2, you're starting at tree number 8. Get the species, which is a code. And I have ash with a question mark because here is that ash tree. And I wondered if people wanted to throw in the chat what they think this ash tree is. It's a very grainy picture, so I'm sure you're really grinding your gears to try to figure it out. So here's a hint. This is what the scar looks like. I can't see the chat, so if someone, I see some chat messages. Oh, I can see the chat now. Oh, I'm seeing a lot of white ash. Nice. For those who aren't sure, so have the seed Samara. What do you think now? You guys are good. I see only white ash. Yes. So we've got a white ash, Fraxinus americana. And when we come across an ash tree, it'd be great if we could also collect additional data. We all know now from the inventory protocol that I went over that I don't think I have the laser. We could come across a male, a female, or a polygamous individual. So if you can indicate that, that's a hugely important piece of data. But if we're in these forests doing inventory data, it's also great to monitor for emerald ash borer. And so we can think about emerald ash borer signs and symptoms as well. I also have this notes section, and you can write down notes like, hey, I encountered brown ash between 21 and 22, because we know that we forget to put those points down, but we might have remembered when we got to the plot. And so you can just be like, you know, it was between 21 and 22, and that could be useful. In the case of this inventory where there are only 264 feet, it's not as critical, but in a really big inventory, sometimes it's a long distance between points. And so knowing that it's in between 2 points is at least going to narrow it a little bit. Oh, I didn't pull that up, but we already went over that. So monitoring for signs and symptoms of emerald ash borer. Emerald ash borer signs. Signs are evidence that it's specifically tied to emerald ash borer. If you find these on your trees, then that means it's emerald ash borer causing the impact. A lot of them you're not going to necessarily come across in reality, like egg masses. But people do come across the adult emerald ash borer beetles, and people do reveal the larvae by peeling away the bark a lot. But you could also see these D-shaped exit holes. And if you did peel back the bark but didn't find a larvae or an adult beetle, you might find these serpentine-shaped feeding galleries. It's still important to report it to the Maine Forest Service, and they can better just identify whether it was emerald ash borer, but it can be a quick telltale sign for you if you come across feeding galleries that are serpentine shaped, that it's likely emerald ash borer. And symptoms, these are things that any stress, any environmental condition that's subpar, or native borers or native disease and fungal pathogens could cause an ash tree to exhibit. So flagging or dieback, early senescence of the leaves start to get yellow, and then they start to cast those leaves early. Epicormic sprouts, these adventitious buds under the bark, as a stress-induced response to any of those conditions, ash trees might shoot out new sprouts in growth in areas that don't really make sense along the main stem. Bark splitting, this one's hard to see, but a lot of times it happens in the upper canopy as emerald ash borer begins to cause harm or other stressors. You can see bark splitting in the upper canopy. And then one of the most critical signs is woodpecker feeding. These larvae under the bark are a great source of protein to woodpeckers, and they certainly will find them. They're very good. It's our best natural enemy of emerald ash borer, woodpeckers. But unfortunately, by the time they start to cause what they describe as blonding here, and then start to really get into the meat of the tree, this tree is going to die. And it's unfortunate, but at least the woodpeckers are doing their part in taking down the emerald ash borer population. So Walali, thank you. I really look forward to getting out into the woods with the group of folks that have registered for the field tour, and I would be happy to take any questions.
You guys have questions, you can put them in the chat. Or looks like we have a raised hand. Elena, do you want to speak your question?
Hi, yeah, thank you so much. That was so helpful. I'm part of WAYS. We have been doing some brown ash inventory, and a lot of times we've encountered trees with bark that's like very confusing. We're not sure what kind of ash it is. It kind of seems to fall between categories. Like it'll have the kind of flat oatmeal-y look, but maybe will also look a little woven. Like I think on your slide for the green ash, there was the bark had kind of like some of it was falling off, almost looking like blonding. And we encounter trees like that a lot, where it's almost like flat ridges, and because the branches grow so high, it's kind of hard to use any other signs to differentiate the trees. I was wondering if you had any advice on that.
Yeah, green ash and white ash can both exhibit this. Were you talking about this right here?
Yeah, thank you. Yes, that.
Yeah. So it isn't blonding. A lot of times that's what gets reported, and I'm sure Mike Prezio, Colleen, Allison are all like sick of hearing about it, but it's this smooth bark disease. So it's really common in white ash and green ash. And it looks like blonding because sometimes they are even these like perfect flattened areas that are really bright. But if you look at of course I gotta go through all of these again. The actual blonding, it's a very stark difference. Of course, this is like early blonding. So like it just happened. It's very recent. And over time, that's going to fade, and it's going to look even closer to what you had just seen on that other slide. But yeah, that can be a real challenge. And then the bark morphology, it just varies between white and green. It can be really hard. That's why squirreling away these other best recognition factors can help to distinguish between the two. But we don't always have leaves, and ash leaves usually readily deteriorate in the understory, so you don't have the ability to pick up the leaf and look at it. It's usually gone by that time. But try to key in on those other ones. I'm happy to hear you guys are out in the ash forest, Elena.
Yeah. Oh, thank you so much. Good to know. So it's the flat bark disease you said is the other
Ash smooth bark disease.
ash smooth bark disease.
Not sure exactly what the cause is. Yeah.
So if we see a tree with that's like the bark is somewhat woven, and even if it's in like a wetland area, it's most likely not a brown ash if it's exhibiting that woven pattern.
Yes. Yeah. No, brown
okay.
ash does not show that woven pattern in its bark. Very scaly and irregular. You can still see kind of grooves, but they're very straight up the tree, and some brown ash. And the ones that exhibit that are really corky. So if you rely on the corkiness of that tree, then you can better distinguish it too. Yeah.
Thank you so much. Thank you.
Great question. We have another question in the chat. Is there anything different about ash coastal locations? Ash in coastal locations?
I think there's a higher abundance of green ash in coastal areas. And I think that's less about the silvics of the tree and more about the urbanization in coastal areas, because green ash is such a common street tree. But that's something I found. I don't know if anyone
Thank
had
you.
anything to add about that.
Okay, there's nothing else on that. The next question is there an easy way to locate the GPS location on your cell phone, an app? Should all of us be letting someone know where we see ash or just the brown ash? And who should we notify if we see signs of EAB?
For signs of emerald ash borer, we want to let the Maine Forest Service know about that. And there's a link to reporting detections or signs of emerald ash borer on the Maine Forest Service webpage for ash. And I think I see Ella working hard. She might be pulling that up and putting it in the chat. And then we would love to hear about everyone's brown ash at the AppCall lab, because we're really interested in seed collection. And again, that doesn't always happen year to year, but when it does, it's great to get an opportunity to get out and collect seed. And we also can connect basket makers to those sites. As the quarantine and emergency order areas evolve, that can be more challenging. Seed collection is not as difficult, because sometimes when emerald ash borer comes to an area, there's a bump of seed, so we can get that opportunity and take advantage of it. There is Avenza is a great app for your phone that you can use the GPS pretty easily, but you got to download the app or the maps from it to be able to utilize that. It's free, so that's another plus. And then there's also ways to drop a pen on Google Maps and other mapping platforms on mobile devices. And so I would encourage you to try those out, and yeah, send those to me, to the rest of the AppCall lab.
Great, that would be a good problem, right, Tyler, to have a lot of people contacting you with
Yeah.
finds.
Yeah, we are interested in ash that's in the forest. So if there's like an ash tree in your front yard, it's likely a planted ornamental tree. Those aren't necessarily the ones we want reports of, but if it's in the forest, I'm always looking to get away from people in the forest.
Great. Thanks. And we had a glitch with our Zoom account. Some people had trouble getting in at the beginning and joined late. I just want to make sure everybody knows we are recording this. It's usually available pretty quickly after the session ends, within 15 or 20 minutes. And as soon as that's available, I'll email that recording out to everybody who registered. We have another question. Can you talk a little bit about EAB monitoring techniques? Do you place traps or create a trap tree for all species or just brown?
You can use any of the 3 ash species for a trap tree. If it looks really straight, really healthy, if it's seed bearing, it's not a good trap tree because we want to save those ones on the landscape. Every time you make a trap tree, that tree is going to die. In fact, you're supposed to harvest it that next year to peel it and check for emerald ash borer larvae. And so we want to choose poorly formed trees. You can't also choose a really low vigor tree that's about to die, because then it's already releasing those stress-induced volatiles. So it's not an effective strategy to girdle an already dying ash tree. You have to choose one that is healthy or somewhat healthy, and that's going to cause it to be really stressed. Emerald ash borer will smell it, and it's our best early detection tool because it really keys in on that. So all 3 ash species work. You want to be in an area where you can easily cut it down and bring it to a peeling event. Get a bucket up into 3-foot sections and then peel away the bark to see for if emerald ash borer larvae are in it. So that's a lot of work. So don't choose a tree that's 20 inches in diameter. You want smaller trees.
For another question. Oh, did you have something, John?
Yes, I was just going to add to Tyler's comment there. It might be good to let the Maine Forest Service know too.
Yeah.
Just for monitoring where we have monitoring going on with trap trees, because it's very helpful information. And I'm sure they'd like to know where the trapping is taking place.
Yeah. Yeah, and if you're at the talk tomorrow, Gary Fish is going to be there as well, talking about the quarantine update, and he'll speak to even trap trees within the quarantine area. They're still valuable, but we do want to prioritize certain areas. It does take time to peel these trees, so we want detections to be worthwhile in updating the quarantine map.
Question for those who aren't able to join the tour tomorrow. Can you recommend some places in different regions of Maine where we can go to meet a brown ash or start getting an eye for them?
Yeah, they like their feet wet. So along streams, along floodplains and river terraces, you can come across brown ash. If you love fiddleheads and you know of a good fiddlehead spot, I'd go check out your fiddlehead spot, because a lot of times they're growing with brown ash. And if you find that one, you should send me that GPS point. And then also there's lots of great sites in Aroostook County. There just is an abundance of brown ash up there. So if you make your way to the county, it's a great drive anyway. And there's lots of ash right roadside that you can find.
Does EAB affect all ages of the ash trees?
Yeah, unfortunately, emerald ash borer can impact a tree down to just 1 inch in diameter. But if we are thoughtful in the way that we manage these forests or try to help make them more tolerant to emerald ash borer, the population of emerald ash borer locally won't get to such a high number that they start to attack those 1 inch trees. And so if we have those 1 inch trees, the cohorts underneath our overstory established, and there's not a lot of low vigor ash trees in the overstory that would boost emerald ash borer populations, we might see those 1 inch diameter ash trees be that generation of ash trees that grow up and can help allow the species to linger on the landscape. If we don't do that, then we see emerald ash borer really devastate these stands.
We have a question from Peter. What are the specs of a good tree for basketry?
That varies from basket maker to basket maker. And the specs actually start outside of the tree in the site. And first, you want to have a site where the water's flowing through the root system. That typically leads to a more quality growth ring that would be suitable for basketry. If it's in really stagnant water, it doesn't typically have a large growth ring, and you don't see the widths you need for basketry. It also looks at the accompanying species. So companion species is a thing. Me and Tom, we harvest a lot of basket wood in sites where there's sugar maple and basswood and these nutrient rich sites, but we don't necessarily harvest any near black spruce bogs because it's less rich of a site, and the growth rings aren't suitable, and the splints become really brittle is what a lot of basket makers share. And then as far as form, you want a really straight tree, something with relatively free of pin knots on the butt log. And you want anything from 5 inches up to 8 inches in diameter is a sizable log that you can pull out on your shoulder, because that's how you bring it to the truck. You don't typically harvest anything lower than 5 inches or smaller than 5 inches.
Must take a while to, I mean, it's hard enough to find one ash, right? So to then try to find the one that's perfect for your basket, that's quite a process. Here's another question in the chat. One of the arguments that I always hear is that if you have ash on your woodlot, you should cut it down while it is still healthy because they are all going to die. What do you say to them?
So that is the phloem reduction strategy. You reduce the resource that emerald ash borer relies on, which is ash trees. You cut away all your ash. The idea is that emerald ash borer can't then spread further. But research has shown that if you cut a lot of ash ahead of emerald ash borer, it simply just causes that beetle to fly further to the next available ash tree. And so you're actually inherently increasing the rate of spread. And then furthermore, it's not a great practice because you're taking away the next generation of ash trees. We never know if an ash tree is going to survive emerald ash borer, maybe genetically resistant to the borer, unless we let it see its course. It gets the impact of emerald ash borer. Who knows, it might survive, and then we can collect seed from that tree. We can do genetic research. It can help advance the science to help perpetuate this tree on the landscape. None of those trees would ever survive a chainsaw. So there's no chance in it surviving if it's a chainsaw. So you have to just think about the next generation. If you're going to cut all the trees, then there's no chance for this tree to linger on the landscape.
Thank you, Tyler. Well, we're at 4 o'clock. I think we should probably wrap it up. Do we have a way that people can contact you guys if they didn't get their questions answered, or if they have more questions after we finish?
It looks like Ella, are you going to put the link in the chat?
I was about to put the link to the APCO website
Perfect.
in the chat. And on that website, every single one of our lab members' emails is on there. So you can reach out to Tyler directly or to any of us if you have any follow-up questions. And Tyler, were you going to say anything about where we meet for the field tour tomorrow, for those of you who are coming?
Yes, I meant to pull that up. I think I forgot to pull it. Hold on.
Yeah.
There we go.
Definitely, as Kelsey says, wear your boots tomorrow if you're coming with.
I did see a comment in there about trees that are larger than 8 inches. Are they still worthwhile for processing? And I have seen basket makers harvest really large trees for certain baskets. So there is a value in those trees as well. And it's even harder to find those, right? Because there's a lot that can go wrong before they get to that size. So if you come across a really quality brown ash that's really large, that's definitely something to reach out to us about. And I'm sure a basket maker would be interested. As far as transporting it out, that could be an adventure. Now I hold that up. There we go. So here are some directions about the field tour. This is the address. We're meeting at the West Appleton Country Club, unless anything's changed. Ella, feel free to chime in on that. And then it's just a 3-minute drive from this location to the Appleton Bog Preserve. But we're meeting here because there's limited parking at the actual field tour site. So the country club's been gracious enough for providing some parking. And then we would climb into some university vans to go to the site. Even at the country club, parking could be limited there. So we may have to park on the grass, and it's a country club. So just drive with care if you do end up on the grass. And then this is a little map of where we're going. This is the country club driving south. This little intersection, this is a dirt road, West Appleton Road. We're going to park along the road right here. Limited parking here, so if you can climb into a university van, the less vehicles we have here, the better, especially with all this rain. And then, like Kelsey had mentioned, please bring some calf-high boots at least for the site visit. Waterproof boots. Bring some drinking water, binoculars if you have them. If not, we have some to hand out. And then weather, it looks like there's probably going to be some rain, so you can scratch the bug dope and focus on the rain gear. And yeah, I think that's it. Oh, I guess it's about a 10-minute walk, and it is slightly broken terrain. It's just nothing like super intense, just off the beaten path. So be prepared for that. And if access is going to be an issue, we can give you assistance getting out to the site.
Thanks, Tyler. And I will, Tyler sent me that document, which I will send out to the list of tomorrow's participants so that you can have your own copy of that. So thank you so much, Tyler, John, Emily, Ella. Thank you for doing this. It's such an interesting topic. There's so much to learn. And we're grateful to have you guys around to help us get up to speed on this. And we look forward to seeing you tomorrow. Awesome. Thank you all for joining. Have a great day.
Sounds good. Take care.
Bye-bye.